But first, if you have looked up into a clear blue sky this summer and noticed a big but lonesome balloon floating away, well, don't worry. There wasn't a kid that accidentally let it go, then watched it disappear with teary eyes. A team of scientists conducted a study using balloons to track heat patterns 12 miles high to better understand how heat rises.
5, 4, 3, 2, 1, go!
Oh, I missed the tree. I missed the tree.
This data is the first of its kind collected for Chicago, and the scientists say they hope to use it to better understand how rising heat will affect different neighborhoods. With us to break it down is Juanpablo Ramirez-Franco, WBEZ environment reporter. Hey, Juanpablo.
Hey, Sasha. How's it going?
Going well. I am so curious about this. Using balloons to chart heat in Chicago. It sounds super cool, but how does it work exactly?
Okay, this is the way it works.
Okay.
So imagine a balloon, regular balloon, not a regular balloon. This is a weather balloon. So it's big, about 5 feet around. Attached to this balloon is a string. At the end of this string is a measuring device. It captures things like heat, moisture, air pressure, and location. They launch it off, and it beams back. It beams back the results back down to the ground, where the scientists are then going to use this data to make new models.
Oh, wow. So this new data is new for Chicago, right?
Yeah, new for Chicago.
So in your reporting, you write that up until now, scientists haven't had what's called a substantial vertical profile of Chicago's atmosphere. So what's the vertical profile that they're talking about exactly?
Yeah, so Sasha, if you and I walk outside together, hand in hand with a thermostat, we'll know that it's something like 82 degrees out. But that's just like the beginning of the story. That means that we know it's 82 degrees on the ground, but heat rises. And the higher you go, the cooler it gets. And about every 100 meters or so, it cools by 1 degree Celsius. And so the vertical profile they're trying to get here is an attempt to get a sort of 3D rendering of how heat rises into Chicago's atmosphere and what it does once it gets there.
So learning how heat rises here and what it does, I mean, why is that important to know?
Yeah, Sasha, this is so important because how it feels on the ground, how hot it feels on the ground is determined by how high that heat rises and how it interacts with the cooler air there.
Oh, okay. So what are they going to use the information for?
Yeah, so all of this goes back to improving climate modeling. So scientists can start to predict how extreme heat will behave and vary across the city, so neighborhood to neighborhood. And this is important because the nearest place that we collect data like this is in one, Davenport, Iowa, or Lincoln, Illinois, neither of which look anything like Chicago.
Right. So these scientists, they launched these weather balloons in 4 different sites. Where were they?
Okay.
And why those places? I'm curious.
Yeah. So one, Humboldt Park on the west side, the Shed Aquarium near downtown and near the lake, important. Greater Grand Crossing and West Woodlawn on the south side. So the idea here was variety. Chicago by the lake, Chicago by the massive cityscape, and then Chicago in its more neighborhood setting. So we have a sense of how heat rises and how it's different and what that all means.
Okay. So this research in Chicago, it's actually part of a federal study led by the U.S. Department of Energy, where they're actually looking at the topography of different neighborhoods, like the size of buildings and the amount of paved surfaces and the density of the tree canopy. And they want to see how hot it feels on the ground, as you were explaining. Why those things specifically?
Yeah, so the idea here is that highly urban areas can experience higher temperatures than outlying areas. And that all has to do with how heat is captured in things like roads, buildings, really non-permeable surfaces. Because when it's captured there, it's then radiated out during the night and then heat rises.
Juanpablo, you talked to Steve Nesbitt, who's a professor of atmospheric science at U of I, about what the scientists expect to find. I want to play a little bit of what he said.
We're going to see that Chicago has microclimates. People usually think about Illinois as a flat place where the weather's the same everywhere, but the buildings actually do impact how people experience heat.
Now, a recent analysis from Columbia University's Brown Institute for Media Innovation, it found that over 80% of historically redlined areas are more likely to suffer extreme summer temperatures than non-redlined areas. I feel like there are not many surprises there.
Yeah, and a lot of what this has meant is that these neighborhoods that have typically been disinvested in, 2 things rise. And that's that 1, they have fewer trees, and 2, they have more impervious surfaces, so asphalt, concrete. all of that is a recipe for locking heat into the ground.
I think of the lake first and foremost as a cooling element here in Chicago. I wonder how the lake plays a critical role, Juan Pablo, in keeping our city cool.
Yeah, so when you think about the lake breeze, here's what's happening. When the sun is beating down during the day, the land actually warms faster than the water can. And so the warm air over the land rises quicker, and now we have a sort of low pressure area. And then what happens is that the cool air that's sitting on top of the lake swoops in to fill in that vacuum. And that, to you and me, Sasha, feels like a cool, refreshing breeze.
Right, that we love so much.
That we love.
We crave. Over the summer, we saw reports that the hottest recorded day on Earth was July 22nd of this year. We talked about it on this program as well. I mean, the world, it's just getting hotter, Juan Pablo. What are the connections then between the data that's being gathered here by these scientists and these larger trends that we're seeing?
Yeah, so let's go back to the urban heat islands for a second, because this isn't a phenomenon that happens with or without climate change. This just means that the urban environment, the way it's built, is built in a way that captures heat. That happens without climate change. Now, what we know is that things are compounding because as things get hotter, and all of a sudden we have urban environments that aren't built to withstand that kind of heat, things get deadly. And so what this does is connect the two and figure out how we can mitigate both.
Yeah, that could be scary. So tell us next steps then for measuring the way Chicago's weather patterns are changing because of climate change.
Yeah, so this extreme heat, this is a first round of CROCUS, that's the Department of Energy's Community Research on Climate and Urban Science
Crocus.
program. CROCUS, that's right. And so
Okay.
this year, it was all about extreme heat. Next year, they plan to focus on precipitation and flooding and how it's impacting Chicago.
So now that we have the ears of some Chicagoans, tell us how we can contribute to helping Chicago stay cooler. I feel like there's got to be something we can do.
There sure is, Sasha, and it's easy. It's called planting a tree. And you don't even have to spend a dime. You know, call 311, report, ask for a tree, bug your alderman about it. There's ways to get trees, and Chicago has a lot to give.
We'll leave it there. That's Juanpablo Ramirez-Franco, environment reporter for WBEZ. Thank you.
Sure thing, Sasha.